say AC circuits, AC circuit simply means refers to as the alternative current is defined as a circuit to which alternative current specifically flow. An AC circuit is referred as the circuit to which alternative current specifically flow. As well as when we talk about alternative current is referred as a current that change periodically or sinusoidally with time in order to reverse the effect of the sinusoidally or periodically respectively, as the case may be. And this is the graph of alternative current. We have this is a graph of alternative current. You see it changes periodically with time. Here is the current, as here is what time. So alternative current is a current that specifically changes periodically with time or sinusoidally with time, and it can also be reversed sinusoidally or periodically respectively. And based on this, we talked about how we can get from here. We have what we call I is equals to I naught sine omega t. We call it equation 1, where omega is equals to 2 by f. We call it equation 2. Substitute equation 2 in equation 1. We have I is equals to I naught sine 2 by f t. We call this one equation 1, equation 3, where I is specifically called instantaneous current, while I naught is referred as the maximal value of current or the peak value of current. The F is our frequency in hertz, and T is our time specifically. Also, we can also have a graph of alternative voltage. Alternative voltage is a voltage that specifically changes sinusoidally with time or change periodically with time. And where we can plot also the graph like this. We have now it's going to be I going to be V is equals to T, where we have something like this too. Where we have the V is equals to V naught sine omega t. We call this equation 1. What is our omega? Omega is equals to 2 pi f. We call this one equation 2. Substitute 2 in 1. We have V is equals to V naught sine 2 pi f t. We call this equation 3 respectively. Where I is instantaneous voltage, the V naught is the peak voltage or maximal value of voltage, where F remains the same thing, frequency and time, respectively in seconds, and as the case may be. Based on these, we can calculate anything given to us. Either we should find the frequency or we find the alternative current, as the case may be. For instance, if you have V is equals to 2 sine 450 pi t, and we are asked to find specifically our f. To find f here, you just say 2 pi f t is equals to 4 pi t. We make f subject a formula. Divide both sides by 2 pi t. We have 2 pi t. Automatically, 2 we cancel 2, pi cancel pi, t cancel t. We have f is equals to 450 pi t all over 2 pi t. So t cancel t, pi cancel pi. F is equals to, when you have the 450, if you have to break down the 450, we are going to have 225 hertz. And remember our peak voltage. The peak voltage will be equals to this is 2. Our peak voltage will be equals to what? 2. And that's all about that specifically goes. And based on this, we specifically proceed to talk about the root mean square. When we say root mean square, root means square. Root mean square is referred as the quantity of heat that have the same heating effect and also have the frequency in a given circuit. We have root mean square. Root mean square voltage. Root mean square voltage is equal to V naught over square root of 2. We call it equation 1. And root mean square is same thing as V naught times 1 over square root of 2. We call this equation 2. But 1 over square root of 2 is same thing as 0.70 like this. We talk equation 3. So to this here we have the root mean square voltage is equal to V naught 0.70. So that's how to get the root mean square voltage. Let's now go for root mean square current. To do root mean square current, we have our I is equal to I naught square root of what? 2. We call this equation 1, which is also equals to I naught times 1 over square root of 2. We call this equation 2. Substitute 2 in 1. We have, no, yes, from here we now have, but square root of 2 is equals to 0.70. We call this equation 3. Substitute 3 in 1. Where we have I is equals to I naught sine times 0.70. So if you times this by this, you have this equation 4, and this is the formula to calculate root mean square current, root mean square current, and root mean square current. That's the formula we are going to adopt to calculate it. And based on this, specifically, we will now talks about the specific current. We talk about the resistance in an AC circuit. Resistance in an AC circuit, we have what? Resistance in an AC circuit. Resistance in an AC circuit is, let's draw the diagram, because resistance is defined as opposition to the flow of current in a given circuit. We just draw this a V, which is connected, which is specifically connected to our R, and this is connected to our current, and these. So this is the circuit diagram of resistance in an AC circuit. And the formula for resistance in an AC circuit is, we can specifically say V is equals to I R. We call it equation 1. From where? From the Ohm's law. Specifically, we want to make I to be a formula. We have, if you make I to be a formula, we have divided by what? R divided by what? R. R cancels R. I is equals to V over R. We call it equation 2. Whereby we can say I root mean square, same thing as V root mean square, all over R, as the case may be, or the I naught is equals to V naught over R, equation 4, depending on what you are asked to be. And this is the formulas of resistance in an AC circuit, respectively. So now let's now proceed and talk about capacitance in an AC circuit. Capacitance in an AC circuit, let's define capacitance. Capacitor is defined as a device that is defined as an electrical device that specifically stores an electric charge, respectively. And we have capacitance. Capacitance in an AC circuit. Capacitance in an AC circuit is, the diagram is V. You connect it with V, where you have, this is a capacitance, and we have here is, then we have our root mean square. This is the formula for capacitance in an AC circuit. And capacitance in an AC circuit, the formula is SC is equals to 1 over omega S. We call it equation 1. Thereby we have the omega is equals to 2 pi F. We call this one equation 1, equation 2. So 2 in 1 we have what? XC is equals to 1 over 2 pi FC. Equation 3. This is the formula we use to calculate the capacitance in an AC circuit. Now permit me to proceed to inductance in an AC circuit. Inductance in an AC circuit. Inductance in an AC circuit, you can draw the diagram of inductance in an AC circuit. This is inductor in an AC circuit. Inductance in an AC circuit, the formula, the diagrams of this is V, which is connected to an inductance coil. We have here is our area, our current, and here is the symbol of AC circuit, the current, the inductance, as well as the voltage. And the formula is XL. XL is equals to omega L. Omega L, we call it equation 1. Then we have the omega is equals to 2 pi F. We call it equation 2. Substitute, we have XL is equals to 2 pi F L, equation 3. And this is the formula we use to calculate inductance in an AC circuit. Now, let's now proceed and talk about series circuits that contain resistance, inductance, and capacitance. What we have here is our resistors R connected with our inductance L, connected with our capacitor C, which in all connected with an alternative circuit or alternative current respectively. So to draw the diagram of this is we will have or we can say the current flow there. We will have the diagrams specifically where we have, you can now say XL is equals to omega L, which is same thing as 2 pi FL. We call this equation 1. Then we have XC, which is equals to omega C, which is same thing as 1 over omega C, which is same thing as 1 over 2 pi F of C. We call this equation 3. And remember, we know our R, which is the same as what R. So we can now say that all in all is, we have all in all now, which is going to be, we have R squared plus XL minus XC, 1 over XC, no, 1 XC all over square, and this we have a half. So we can make this to be Z. We have Z is equals to, here we have what? R squared plus XL minus XC all over square. We have here will be square root because of this sign. Then from here, we can now say, since our XL, we have the value of our X, we have the value equals to Z is equals to square root of R squared plus bracket open 2 pi FL minus 2 pi FC all in square. And this is same thing as the impedance respectively. So in a nutshell, we can also derive this equation and say the V is equals to IR. We have equation 1, right? So where we have make I as the formula, I is equals to, we have the V root mean square, R root mean square is equals to what R, as the case may be. We can also have this. In a nutshell, we can also say, based on this, we can also say, I think we are already done, where we have this value can be in form of root mean square. I root mean square is the same thing as V naught sine 2 pi F T all over R, or we say V is equals to, we can also say this is for V, sorry, this is for V. Then we have this can also be I naught sine 2 pi F T all over R, as the case may be. So if we want to get generally, we can say the V is equals to, we have what? The I is equals to the V naught over roots plus root square root of, we have what? Bracket open, then we have WL minus WC square, where we have refers as the total opposition to the flow of current that is offered by a mixed reactions, a mixed circuit which contain capacitor and resistance, inductance, as well as the capacitors, as the case may be. We also proceed to talk about fundamental frequency. A fundamental frequency is defined as the maximal current that specifically obtained in a circuit, that specifically when its maximal current specifically obtained in a circuit that's obtained, or in a circuit that's made of inductance, capacitance, and resistance respectively. And here you are plotting I over F, and where we have this. So here is our fundamental frequency, or we say resonance frequency. We call it resonance frequency. So resonance frequency, I think we have talked about resonance. And resonance is Z is equals to, I think we have talked about that. Z is equals to R square. We have V naught over plus 2 pi F L minus 2 pi F C square. That's all about resonant frequency. No, that's all about the impedance. I think I've talked about impedance. So let's talk about resonant frequency. Resonant frequency here is going to be our frequency, the maximum frequency, and it's current and it's high, where is F naught. And F naught is equals to 1 over 2 pi F over XL. And in a nutshell, we now talk about the power in an AC circuit. The formula for power in an AC circuit is equals to I naught times R. I naught times R. That's the formula for power and resonance frequency. This leads to the end of a summary of an AC circuit. I remember I myself, Muhammad Nasser Abdul. Thank you so much for listening.